Alright, so the last set of problems, numbers 13 through 18, we're going to get through all of these in this video. Number 13, we are going to first calculate the determinant of a 3 by 3 matrix. So to do this, we look at this first row right here, and those are going to become all of the coefficients for my problem. And then I'm going to take it and cross out the column and then write the resulting matrix. So if I first cross out this column, okay, let's cross it out. I'm going to cross that out and look at this matrix that I'm left with. I'm left with a matrix 3, 1, 2, 4. Now, there was my coefficient. I don't know where I put that, why I put that 2. I'm so sorry. That should be a 6. And then a 5 over here. Okay, those are all going to be my coefficients. Okay, so now if I now cross out that and then we're going to take that value of 6 and we're going to multiply it by the determinant of the matrix created when I cross out that column. So if I cross out this column, then I'm left with the matrix 2, 0, and then 1, 4. And then I'm going to multiply 5 by the matrix created when I cross out that column with the header of 5. And I'm going to be left with 2, 3, 0, 2. Okay, again, to find the determinant, you cross multiply and subtract. So it's going to be 1 times 12 minus 2, which is 10. And then minus 6 times 4 times 2 minus 0, which is 8. And then finally, 5 times 4 minus 0, which is going to be 4. And now I'm going to multiply all of those out. So 10 minus 48 plus 20. And I'm going to simplify that to get negative 18. Alright. Now, to find the area of a triangle, we're also going to have to do the determinant of a 3 by 3 matrix. For this triangle, my vertices are 2, negative 2, 1, 3, and negative 3, 2. So the first thing I'm going to do is I'm going to make a matrix with those values. For my x and y, I'm going to make those in columns. So it's going to be 2, negative 2, and then 1, 3, and then finally negative 3, 2. Now I'm going to have this magic column of 1s. Now we kind of talked about in class that there is a very long, complicated mathematical explanation as to why that column of 1s works and finding the determinant works, but that is how we do it. So we're going to find the determinant of that matrix. And so we're going to write it like this: 2, negative 2, 1, 1, 3, 1, negative 3, 2, 1. Okay, again, those lines on either side of that indicate we're going to find that determinant. Okay, so I'm just going to erase this word determinants because we already have those symbols that tell us that we're finding the determinant. So again, we're going to take the header of each column, 2, minus, and then a negative 2, and then the 1. And we're going to take the resulting, when we cross out the row and column, the resulting smaller 2 by 2 matrix. So that's 3, 1, 2, 1. And then for negative 2, if I cross out that column and row, I'm left with 1, negative 3, 1, and 1. And then if I take that 1 and I cross out that column and row, I am left with the determinant of 1, 3, negative 3, and 2. So again, to find the determinant of a 2 by 2 matrix, I'm going to cross multiply and subtract. So I'm going to copy this 2 over. 3 minus 2 is 1. Plus, minus a negative just turns this into a plus 2. And then 1 minus negative 3 is actually plus 3, so that's a 4. And then finally, I'm going to do 1, and then 2 minus negative 9 will actually give me a positive 11. And then I just simplify that expression. If I can 2 times 1 plus 2 times 4 plus 11, so that's 2 plus 8 plus 11, and 2 plus 8 plus 11 is 21. Okay, now once I get that 21, I need to find the area of that. Oops, I didn't mean to put that one there. So now I'm going to take 21 and I'm going to divide it by 2, and that's going to give me an area of 10.5, and that's going to be in units squared. So there is my area of the triangle. So once I find the determinant, I then need to divide by 2, and that will give me the area. Alright, so for translations, I am going to have to use the original matrix. So I'm going to take all of my coordinates. So this one is 2, 5. This one is 6, 8. This one is 6, negative 4. And it doesn't really matter which one you start with or which one you label. I am going to start, however, with the 0.25, and I'm going to work my way around clockwise. So my original matrix that I'm starting with is going to be the x and the y value. X's are going to be my first row, y's are going to be my second row. So 2, 5, 6, 8, 6, negative 4, and 2, negative 7. Okay? And then what we're going to do is we are going to apply a transformation matrix. Now this tells me to translate the figure 2 units up and 5 units left. So that means if I'm going to have my x row, this moves left and right. So since I'm moving 5 units left, I'm going to add negative 5 to all of my x values in the original matrix, the pre-image matrix. And then I'm going to add 2 to all the y values since I'm moving 2 units up. Okay, now this is called my pre-image. This is called the transformation. My computer's acting up right now. And then finally my result is going to be the image matrix. So I'm going to just do 2 plus negative 5, that's going to give me negative 3. And then just add all of those corresponding values. So all of my coordinates are moved to the left 5, and they are moved up 2. So there's your final matrix. Again, you can label them however you want. But this is the answer that we're interested in. We're interested in having you give the image matrix. So this is what we would call the image matrix. Alright, now to rotate 90 degrees counterclockwise, you will be given all of the different matrices, but in this case you're going to always want to start with whatever matrix you're multiplying by for the rotation or the reflection. You're going to start with before the xy matrix. And that's just so that you can multiply. So this is a 2 by 2 matrix, and this is always going to be a 2 by something matrix. In this case it's a 2 by 4. So you always want these numbers to match here. Okay? So again, I'm going to take that, I'm going to take that original pre-image matrix. It's supposed to be an 8, 6, negative 4, 2, negative 7. And I am just going to now multiply those two values. Remember, or those two matrices, it's always row times column. Okay? So when I finish, I'm going to get a negative 5, negative 8, 7, 4, 2, 6, 2, 6. Notice all that did is it put all my x values for y, and it negated my y values and made them my x value in my image matrix. So again, that's how a 90 degrees counterclockwise rule works, like when you worked with geometry. Alright, last page. All of this last page you can use a calculator for, so you do not need to worry about having to do these problems without a calculator. Alright, so this one first tells me that it wants all of the values for the store in columns, and then the type of book should be my rows. So this is the matrix that you will get when you do that. So in this case, this is my downtown and this is my suburban store, and then these are my paperbacks, hardback fiction, and hardback nonfiction. Okay? Now, in this case, they tell you that they sell for $8 for the paperbacks, $25 for the hardbound, and $35 for the hardbound nonfiction. So if this is already a 3x2 matrix, I know my matrix I'm going to multiply by is going to be, again, have to match. So that since they give me the prices of each of these items, of each of these rows, I know that for my matrix that I'm writing for the prices, my column headings have to match, because in order to multiply with word problems, your column headings have to match the row headings in the other matrix. So the one I get here is going to be just a 1x3 matrix. Okay, so notice my column headings here match the row headings here. Now I'm just going to multiply. Remember, to multiply, I do row times the columns. So this, I know my resulting matrix is going to be a 1x2 matrix. And so when I do that multiplication and add them together, I know my downtown store made 5,719 and my suburban made 2,514. So that gives me my total for the downtown store and the suburban store. And again, you want to put your dollar signs on here so I know you know the units. For these last ones, it's just a matter of plugging them in your calculator. So I've already have these matrices in my calculator. To do inverse, you want to hit second matrix, select matrix E, and then just do your inverse sign, which is right there the same as the matrix. Hit enter. Gives you in decimals, so you're just going to hit math, enter, enter, and it will turn everything into fractions for you. Okay, so I'm just actually going to take a quick screenshot of this and put it on my, put it on my answer key here. Okay, so that's going to be your answer for letter A. For letter H, this means find the determinant. And this is multiply. This is 4 times the matrix B. And then times the matrix C. Okay, and then A times B is, again, you're just multiplying. Okay, so all of those you're literally just going to plug into your calculator and then be able to have your answer. Alright, so here are all your answers after you plug them in your calculator. If you have any questions, I'll see you tomorrow. And I just remembered Jesse was supposed to give you a shout out here. So good luck on your quiz tomorrow.